In this screencast, we're going to practice drawing the sun's path on a celestial sphere. Depending on where the observer is located, the sun's path will change throughout the year. We will start with an observer that is located at 40 degrees north latitude. Here is my celestial sphere with all compass directions already labeled. Up in the right-hand corner over here, I have an illustration of Earth with the three major lines of latitude to help me draw my sun's path. We're going to start with an equinox. For every observer on Earth, during an equinox, the sun will rise directly east and set directly west. This is because the equator is getting the most direct sunlight. Now I have to figure out where to look for solar noon. If I am located at 40 degrees north latitude, I would ask myself, how far am I from the place that's getting the direct sunlight, which would be the equator? Since I am 40 degrees away from the place that's getting the direct sunlight, solar noon would be located 40 degrees away from the zenith, 90. And because I am looking south to see solar noon, I would draw solar noon 40 degrees away from the 90 in the southern part of my celestial sphere because I am looking south to see solar noon. So if I'm located at 40 degrees north, this is what the sun's path would look like on an equinox date. Now we will draw the sun's path as seen by an observer at 40 degrees north during a summer solstice. During a summer solstice, the northern hemisphere is tilted towards the sun. So for every observer on Earth, the sun will rise north of east and set north of west. To figure out where solar noon would be, again I ask myself, how far am I from the place that's receiving the direct sunlight? In this case, direct sunlight is at 23.5 degrees north. Therefore, I am 16.5 degrees away from that 90 degree light. I would count 16.5, so we have 10, 15, 16, and I know that it's in the southern part of my celestial sphere because I am again looking south to see solar noon. Finally, we will draw the sun's path as seen by an observer at 40 degrees north during a winter solstice. Because the southern hemisphere is tilted towards the sun, for every observer on Earth, the sun will rise south of east and set south of west. Now to figure out where solar noon is, I look at how far I am from the place that is receiving the direct sunlight. I know the direct sunlight is over the Tropic of Capricorn, and that is 63.5 degrees away from my location. And again, from my location, I am looking south to see solar noon, so I would count 63.5 degrees away from the direct sunlight, and there's solar noon. And this is how the sun's path would appear to change to an observer located at 40 degrees north throughout the year. Now we will draw the sun's path and how it appears to change for an observer located at the equator. Again, we will start with an equinox date, because on an equinox date, the equator is getting the most direct sunlight. For every observer on Earth, the sun will rise directly east and set directly west. Because I am located at the equator, and the equator is getting the most direct sunlight, solar noon will be at the zenith. Now we will draw the path for a summer solstice. During the summer solstice, the northern hemisphere is tilted towards the sun. So for every observer on Earth, the sun will rise north of east and set north of west. To figure out where I look for solar noon, I ask myself, where is the sun directly overhead and how far am I from that location? Since I am at the equator and the sun is directly overhead at the Tropic of Cancer, I am 23.5 degrees away from the location that is receiving the direct sunlight, and I am looking north to see the direct sunlight. Therefore, in the northern part of my celestial sphere, at 23.5 degrees away from the 90, that's where I will see solar noon. During the winter solstice, the southern hemisphere is tilted towards the sun. Therefore, for every observer on Earth, the sun will appear to rise south of east and set south of west. To figure out where solar noon is, I ask myself, how far am I from the place that's getting the direct sunlight? The direct sunlight is overhead at the Tropic of Capricorn. I'm looking south to see solar noon, and I am 23.5 degrees away from the direct sunlight. So 10, 20, 1, 2, 3, 5, right about there. And this would be my path for the winter solstice.